All right, let's get mouse buttons into our input manager. The first thing we want to do is bring in the array type. So we do include array. I want an array because I want a fixed size. I don't want this to grow. I want it to be not the vector, but it's still a linear container. So it works pretty much the same way. It just cannot grow, which is good. For the member, I want this to be a standard array of type bool and length 6 indexes, because you want to have, like, 0 is going to be unused, and then 1, 2, 3, 4, 5 are used, and 6 is, yeah, you want 1 index more. So 5 will be the last index, 0 will be, yeah, that makes sense. There's 6 indexes. 5 will be the last index that is valid. I might be one off there, we'll see. So that's our array of bools, 6 indexes long, and let's call that button states, I guess. That's all we need to do here. It only contains bools, and it has 6 of them. If we go to, we want the events to be handled first. So if we go to the event queue, event polling, it's in update here somewhere. Here we go, on mouse button, up and down. So let's start with down. Go to definition. No, not peak. I want to go to definition. There we go. On mouse button down, we get a mouse button event where we can get event button. Let's see what that is. That is an unsigned int. I'm pretty sure that's the value we want. Let me double check my sheet paper. Yes, that is the value we want. So what we do is button states index on the button value, set it to true. The button is down right now. In mouse button up, set it to false. There we go. That's all we need. And so is mouse button down, then is down here. Is button down. It receives a button code, and all you need to do is the same thing we do for the keyboard states. Return equals 1 and use the button code that gets passed in. All right, that's the argument here. So you ask, is this button down, passing the code? It looks up into the array. If the value is 1, it returns true. That's all we need, I'm pretty sure. Let me think. We probably want to make this a specific type so we can't pass in any integer, right? An integer can be negative, that would be disastrous. An integer could be very, very large, and that would also be disastrous. We should really, like, the lazy way is to make sure that SDL assert button code is less than button states size. Right? We make sure that we can't go over. Notice that this is something we can do on our array because we're using a C++ standard array. It's a good container that knows its own length. We cannot call size on key states. Key states is an old C-style array, so it's just a pointer and it doesn't know its own length. So you can't, let's see, call anything on it. It's just a number, right? It's just an address. The only thing you can do is dereference it, but even then, because it's not pointing to an object, only pointing to an int, doesn't help us at all. So this is good for safekeeping. Let's try this code. If I go to Pong, we have our input here, we have our update. So in the update, after all of the update stuff, after we have updated input, let's try if input is button down, want to pass in SDL button left. So if the mouse button is being pressed, I don't know, just see out something. See out, please. So now every frame, for as long as I'm holding the button down, this should be printing rather. Trace is what you do in ActionScript. I need to include IOStream here because that was apparently not available yet. There we go. Let me make sure this works. Yeah, there we go. Whenever I press, it traces poo-poo. And so this is the main difference between events, the way we have done them before, where you click once, you get one event. When you release, you get one event. Now we have this continuous input, right? I want my character to move for as long as I'm holding the button down. And so just checking it every frame now gives me that input for as long as this button is pressed, which is convenient. And sometimes you want the other way, sometimes you want this way, so you should probably support both. But the other thing is more difficult to do now that we have broken all of our objects apart. Generally, you want to look into an event system or broadcasting system. They're the same thing. But to be able to pass messages between objects, that's elegant, but it's way overcourse for this course, so don't worry about it. But yeah, here's how we use it, right? Is button down, whatever button you want to use. Same thing with is key down. So now we have to decide if we want to run this type of code in... We definitely don't need on key up anymore here, so I'm going to remove this. There's nothing calling the event handlers in Pong. So I'm going to remove all of them and make my Pong class shorter. Go back to the header, remove them here too. So now Pong immediately became more interesting. Sorry, more better. What was I talking about? Continuous input. Yeah, if you want to, you can save the left paddle and the right paddle and the ball as separate pointers in this class, as well as putting them in the list, because the list takes care of updating and rendering and hopefully input. So you still want the list, but you can keep the pointers separately so that you can speak to them immediately, right? So you can do your own manual kind of, if, arrow keys were pressed, control the left paddle. If something else was pressed, if the mouse was moved, control the right paddle. It's not elegant, but it works. I would prefer, I believe, a solution where you pass the input manager into the object as well, so that each object can check the input manager for whatever it cares about. You still need to be able to differentiate the objects at some point, right? The left paddle needs to know that it is the left paddle. So that's where the trickery comes in. Again, it's a puzzle. Feel free to try to solve it. However, I'm going to have a think on it. We sort of discussed it in the class today. And there's interesting ideas of passing the key codes that the object should care about into the object. But the devil is always in the details. Like on the surface, it sounds like a great idea. I need to actually try that code out a little bit. Maybe we'll work it out at Kodstuga tomorrow. But let me see, we have this thing. I wanted to do one more thing. Right now we're using this define for getting button values. What we can look at is something called an enum. We haven't talked about this, but beyond making classes, that's a user-defined type in C++. We create a class, we have a new type. We can create enums, which is a simpler type for numeric values. Right now, our mouse button function is button down, takes an integer. But an integer is mostly invalid. Like all negative values are going to be invalid, 0 is going to be invalid, and anything larger than 6 is invalid. So literally what you want to have here is a type that can only hold good values. And an enum is perfect for this occasion. It's what STL used for the scan codes. So you've already seen this, but the syntax, let me show you, I think. If we do an enum and call it MouseButton, because we want it to have a clever name. Notice I'm just putting it outside of the input manager class. So this is the input manager class. I'm just putting it above it. You can put it below it, but it's in the same file. And I do that just because whoever is using the input manager, or rather the user, let's see here. where you need mouse button, you are probably also needing input manager or vice versa. So they belong logically together. By declaring it here above the input manager, we can use this type inside the input manager. And anyone who uses the input manager has access to this type as well. So here's the order from the SDL source code. So in my mouse button enum, I can name these left, middle. Notice that they are separated by a with a comma each line. Right, X1 and X2. I think those are, I don't know, side buttons or special buttons on your thing. Middle is the scroll wheel. By default, these values are now 0, 1, 2, 3, 4. You can control the numbering. So you can say that left is 5, and now middle is 6, 7, 8, 9. It'll go in order. But you can assign arbitrary values here. Right? You can make this 5 and this 9, and then do whatever you want. Mouse button, whenever you pass it anywhere, is only going to be able to hold these specific values. In code, the way, right now this is useless, we're going to fix it, but in code, the way this improves our code, if we go to pongcpp where we call with SDL button left, this is fine, but it's not type safe. The compiler can't check this. This is literally, if we hover over the definition, only passing in, it's the same as writing is key down 1. Provides no information to the compiler or to a reader, really. The name is pretty good, but there is no help from the compiler, and you want that help. So now that we have a custom type for it, we can use mouse button, : left. That's much clearer. And if we change the interface of the function in input manager, notice it takes an integer and the enum can automatically convert to int. So we can still call it like this, it works, but the benefits comes from doing this instead. So we pass in a mouse button, B. And now the only values that can get passed in are valid values, and they will be checked by the compiler. We have to make sure that this is also a mouse button B. We don't need the assert anymore. We can still assert. We don't need it. There shouldn't be any way of getting it wrong. So now we just use the value B here instead. It's a numeric. And all we need to make sure is that the enum actually matches what SDL suppose it does. So we start, I'm actually going to assign them all the values. You don't have to, because now you start on 1. They should grow. This becomes 2, this becomes 3, this becomes 4, this becomes 5. But to be absolutely sure that I am getting the same values SDL is defining, I will use the SDL defines. These defines are macros. I have already explained that we should never use macros, but SDL is a C library. They love macros. We use enums for this kind of work instead. Again, because it gives us type safety. Now there is a type that only has the values left, middle, right, x1, x2. They are numbers, but type-wise, protection from the with the compiler-wise, it's mouse buttons. Literally a mouse button. It's kind of like making a class with just static const members. But enums is more compact, it's faster, it's very clever for using in interfaces. Very, very practical for stuff like this. Can only pass in mouse buttons. Perfect. So yeah, I think this is what we need from an input manager so far. Like I said, work on like getting the scroll wheel in if you want to use the scroll wheel in your game. We haven't worked with, well, I think that's it actually. There's a lot of different events you might care to deal with. But yeah, let me see that it all compiles still, that I actually get the output I want. There we go, sweet. How much time did this take? Yeah, still too long. Yeah, I think what we did in class today is we extended entity to take an input manager. We might want to because it's sort of convenient for entities to have the input manager available. You should never copy the input manager. It should only ever exist a single copy, a single instance. If I look Pong header, we have the input manager here. So we might want to extend entity so that it takes a reference to an input manager. That would be a pointer to an input manager, because we can't properly hold a reference. It needs to be initialized. And so that gets tricky fast. But it's also a little bit messy, because maybe I don't want all entities to have an input manager. Yeah, no, okay. I'm going to make one more video where we feed the input manager into the entity hierarchy, so all entities have it available. And then you can choose which way you want to go. If you want to add it to your entity, if you want to just let the Pong class deal with the input. I won't judge either way. But yeah, one more video. Bear with me.